Hello students, welcome to Eshwari Thaniksha channel. Students, in this video we are going to learn one super trick to solve 4 types of questions. So in the NEET previous year question papers, if you see, you can see this type of questions. That is, molecules will be given like this and you have to compare their bond order, their stability, bond length, and you should also say whether it is diamagnetic or paramagnetic in nature. So in this video, let us learn one super trick to solve such types of questions. So first, let us take oxygen O2. So students, what is the number of electrons present in oxygen? In oxygen totally 8 electrons will be present. So in 2 oxygen, that is O2, 8 plus 8 is equal to 16 electrons. So totally 16 electrons will be present. So students, if a molecule has more than 14 electrons, we will be using this type of energy levels of molecular orbital in the increasing order of their energy level. So you know about bonding molecular orbital and anti-bonding molecular orbital. So if a star is present like this, it is called as anti-bonding molecular orbital, and this is called as bonding molecular orbital. Sigma 1s is bonding molecular orbital, sigma star 1s is anti-bonding molecular orbital. And here you can see there is equivalent sign, meaning is they are degenerate orbitals. Degenerate meaning is both are having equal energy. So here also anti-bonding molecular orbital, you can see equivalent sign is present, which means both are having equal energy. So we will be using this type of energy levels when the system has more than 14 electrons. So here we have 16 electrons, therefore we are going to use such type of molecular orbitals in the increasing order of their energy level. So now let us fill the electrons. So totally we have 16 electrons. So we are going to fill those electrons. So 2 here, 2 plus 2, 4, 6, 8, 10, 12, 14. So here, since it is degenerate orbital, 1 electron here and then 1 electron here. So totally 16 electrons. So students, whenever there is unpaired electrons, so unpaired electron if it is present, we call it as paramagnetic. So now O2 is paramagnetic in nature. Paramagnetic in nature. So now let us calculate the bond order. So bond order can be calculated using the formula 1 by 2 number of electrons in the bonding orbital minus number of electrons in the anti-bonding molecular orbital. So this is equal to half into how many electrons are present in the molecular orbital. So you can just count 2, then 4, 6, 8 and then 10. So totally there are 10 electrons. So totally there are 10 electrons minus anti-bonding molecular orbital, how many electrons are present? So here you can see 2, 4, then here 5, 6. So totally 6 electrons are present. So you will be writing 6. So this is equal to 10 minus 6 is 4. 4 divided by 2, which is equal to 2. So you will be getting bond order as 2 for oxygen molecule. So next we will go for O2 plus. So O2 plus, how many electrons will be present? In O2 totally there are 16 electrons. O2 plus meaning is we are removing 1 electron. Remove 1 electron. So totally it will become 15 electron in O2 plus. So now let us fill the electrons. So 2, 4, 6, 8, 10, 12, 14 and then 1 electron here. So totally 15 electrons. So students, since here unpaired electron is present, it will be paramagnetic in nature. So this is paramagnetic in nature. So now let us calculate the bond order. So bond order is equal to, what is the formula? Half into NB minus NA, that is number of electrons in bonding orbital minus number of electrons in the anti-bonding molecular orbital. Half, so bonding orbital 10 electron minus anti-bonding 5 electrons. So this is equal to 5 divided by 2, which is nothing but 2.5. So what is the bond order in O2 plus? It is 2.5. Next we will go for O2 minus. So how many electrons will be present? In oxygen totally there are 16 electrons. So in O2 minus how much it will be? It will be 16 plus 1. Minus meaning is 1 electron we have to add. So totally it will be 17 electrons. So now let us fill the electrons. So 2 electron, 4, 6, 8, 10, 12, 14, 16, 17. So totally 17 electrons. So students, whether it is diamagnetic or paramagnetic in nature, you can see here one unpaired electron is present. Therefore, it is paramagnetic in nature. Paramagnetic. So let us calculate the bond order. So bond order is equal to half into number of electrons in the bonding molecular orbital, which is 10, minus in the anti-bonding orbital 7. So which is equal to 7, which is equal to, so 10 minus 7, which is equal to 3. 3 divided by 2, which is nothing but 1.5. So what is the bond order in O2 minus? It is 1.5. Next we will go for O2 2 minus. So how many electrons will be there? In O2 it is 16 electrons. 16 electrons. So in O2 2 minus it will be 16 plus 2, which is equal to 18 electrons. So now let us fill the electrons. 1s2, 2s2, 1s2, then 2s2, 2pz2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So all the molecular orbitals are filled. So whether it is diamagnetic or paramagnetic in nature, so you can see there is no unpaired electron, all are paired. So if there is no unpaired electron, we say it is diamagnetic in nature. So this is diamagnetic. So now let us calculate the bond order. So bond order is equal to half into number of electrons in the bonding molecular orbital is 10, minus anti-bonding molecular orbital electrons are 8. So which is nothing but 10 minus 8 is 2 divided by 2, which is equal to 1. So this is the bond order. So now we are going to, just now we calculated bond order for O2, O2 plus, O2 minus and O2 2 minus. So what is the bond order we calculated? So bond order for oxygen we got it as 2. For O2 plus we got 2.5. For O2 minus we got 1.5. And for O2 2 minus we got it as 1. So what is the trick we are going to use here? The trick what we are going to use is bond order. When it increases, the stability also will increase. Stability also will increase and bond length is going to decrease. So this is the super trick we are going to use to relate all these three: bond order, stability and bond length. So now let us write the bond order. Bond order. Bond order. So which is having highest bond order? So you can see O2 plus. So O2 plus has 2.5. So you can write O2 plus bond order is greater than O2, and then O2 minus, and then O2 2 minus. So this is the increasing order of bond order. So next we will see stability. Stability. So what is the relationship? So you can see the relationship is bond order is directly proportional to stability. When bond order increases, stability also will increase. So therefore stability also you can write same order. O2 plus has more stability when compared to oxygen, when compared to O2 minus, when compared to O2 2 minus. So next we will go for bond length. So bond length, what is the relationship? Relationship between bond order and bond length. They are inversely proportional to each other. When bond length increases, when bond order increases, bond length will decrease. So now we have to write this in the reverse order. That is, bond length of O2 plus will be less than O2 will be less than O2 minus, which will be less than O2 2 minus. So this is one of the super trick which you can remember to calculate this type of problem. So if you see in previous year question paper, more number of questions would have come based on this. That is bond order, then stability of the molecule, compare the bond length between the molecules. So such type of questions would have been asked. So use this one super trick. So using this one super trick, we will be able to solve all such kind of problems. So if you like the video, you can share this video with your friends and also subscribe the channel. So I'll meet you in the next video, students. All the very best.